All right, we're going to do 4.2 notes today, which is about position, velocity, acceleration, which we've already talked about. So usually position, when we're talking about like dropping something from a building or something like that, is usually S of t. Sometimes they use other functions, but that's the normal one. And usually when you're talking about something going left and right along like an x-axis or a window pane, we do x of t. So you need to know that S prime of t equals V of t, and you need to state this in your problem. If we're talking about horizontal, X prime of t equals V of t. Acceleration is the second derivative position, which is the first derivative velocity. That's acceleration. And if we're talking right or left, same story. So you need to make sure you tell the person grading it that you understand these relationships. Now you're going to do worksheet 4.2. And it'll be due Monday, and we're having a quiz 4.1 on Monday, and I think we're turning 4.1 in on Monday as well. So this says, now we will revisit an idea we introduced in topic 3.6 when we studied motion in calculus of a straight line. When we studied this idea, we were concerned with the concept of position, velocity, acceleration, and speed. And we're going to talk about what speed is. As a matter of fact, it's right here. It's the absolute value of velocity. As discussed earlier, position is a function with respect to time, usually x of t or s of t. If the object is moving along the x-axis, we usually use x of t. He put y of t for vertical, but most of the time it's s of t. So he's got on here for s of t equals this problem. We want to find the position on the number line. So we're going to plug 0 in here. So when you plug 0 in here, we get -3. So at time 0, we're right here, -3. Okay, and then at time 1, we're going to plug a 1 in there. We're going to get 1 minus 2 minus 3, which would be -4. So at time 1, we are here. So at time 0, we're over there to the left. And at time 1, we're at -3. Time 1, we're at -4. And we're just going to continue to put those numbers inside the problem to get this stuff. So I probably should have labeled this. This is at time t equals 0, t equals 1, and then let's plug 2 in. So we get 4 minus 4 is 0, minus 3 is -3. So this is also at time t equals 2. Plugging in 3, we get 9 minus 6 is 3 minus 3 is 0. So at time equals 3, we're at 0 right here. And then plug in 4, and we get 16 minus 8 is 8. 8 minus 3 is 5. So we are out here at time t equals 4. Now right here's velocity. So this is something I gave you last week, but this is the direction. Velocity is going to tell us what direction the object's moving. So when we're talking going left and right, when the velocity is greater than 0, it moves right. Velocity less than 0 moves left. Velocity equals 0, the object stopped. Now we're talking about going up and down. If this velocity is positive, the object's going up. If the velocity is negative, the object's coming down. And again, velocity equals 0, the object stopped. Speed is the absolute value of velocity. It's always a positive value. Okay. Let's go down here. All right, acceleration. The definition of acceleration is the change in velocity over time. We know the derivative can be, say that, you can read that, a of t, equals the first derivative of velocity equals second derivative of position. So the position function, v of t, we can now determine both the velocity and acceleration. On your cards, you have two devices that changes the acceleration. What are they? Well, that would be the accelerator or gas pedal. And the other thing is the brake. I hope you're good at using both of those. Coming on over to the next page. Down here, acceleration, that's horizontal. When your acceleration's positive, greater than 0, it's being accelerated to the right. So like if you were running to the right and the wind blew you in the back, the wind would accelerate you. The object is accelerating to the left when the ft is negative, and when ft equals 0, the velocity is not changing. It's a constant. That we'll talk about what that'd be like. Now this is going up or down, so if acceleration is positive, it's pushing the object up, accelerating up, like a rocket taking off. And if the acceleration is less than 0, we're pushing the object down, or it's accelerating down. And if velocity is 0, it's the, if AT is 0, the velocity is still not changing. Just because an object's acceleration is 0 does not mean it's stopped. That means the velocity is not changing. What device on your car would make that equal to 0? That would be our cruise control. You hit the cruise control and the car is supposed to go the same speed. Also, just because you have a positive acceleration doesn't mean you're moving it to the right. For instance, suppose you were walking to the right when a sudden large wind blew to the left. What would occur? Well, the thing that would occur was, and most of you probably either walked or jogged into the wind, and you probably all know that this slows you down. Slows you down. A particle moves along an x-axis with the position of this, and we want to know what is the velocity. Now, I would like you to put s prime of t, because you are now supposed to show the grader on the AP test, you know, this relationship. And so we would do the derivative of this and get 2t minus 4. And then a of t is the derivative of this, and you should probably put s double prime of t equals v prime of t equals acceleration. So we do the derivative of this, and the derivative of this is 2. So the acceleration is a constant 2. So we want to know what all these things are going in acceleration. So these are 2 the whole way because there's no variable. So it does not matter what you're doing. The object has acceleration of 2. Now we want to do the position at time 0. So we plug 0, 0 in there, and we get 2. And likewise, we're going to plug all these other numbers in there, and I've already done this. So this should give me -1. This should give me -2. This should give me -1. This would give me 2, and this would give me 7. And then we're going to take all these numbers and plug them in here. So if I plug 0 in here, 2 times 0 minus 4 gives me -4. And likewise, we're going to plug all the rest of these numbers into velocity. And we would get -2, we would get 0, we would get 2, 4, and 6. And then the absolute value means we're going to put absolute values around these answers. So that makes all of them a positive, the speed of the object. I guess I said it makes all of them positive. 0 is not a positive, but it doesn't really matter. Now we're supposed to describe this thing. So what we want to know is the particle speeding up or slowing down? So the two things, actually we're not supposed to talk about this yet, it's later, but I'm going to tell you right now. When the velocity and the acceleration are the same sign, an object speeds up. When they're different signs, it slows down. So if you look over here, this is positive for everything. Over here we have different signs. So if the sign is negative and positive, this object is slowing down because those signs are different. So this means the object is moving to the left, but the wind is blowing, or whatever is accelerating is going to the right. So this is slowing down. And then here we got another negative, and that's still positive, so it's also slowing down. Right here, this means the object is stopped. It is stopped because velocity is 0. So that'd be like a rock laying on the ground, the wind's blowing, but it doesn't move it, so it's stopped. Here we got positive and positive, so those signs are the same. So since the signs are the same, this one is speeding up. It's because it's moving to the right and being pushed to the right, so speeding up. We got positive, positive again, so this one is also speeding up. Positive, positive again, this one is also speeding up. Okay, so we were supposed to complete it. And we're supposed to put where the particle is on the number line down here. So we were going to do it wanted me to do the exact same thing that we did on the above stuff. So we're supposed to plug in our number. So when I plug t equals 0 in, and we're talking about this original equation right here. I plug 0 in, I get 2. So let's see, 1, 2, so it starts right here. So that's t equals 0. And going ahead and plugging 1 in is going to give me -1. So I'm going to be right here at t equals 1. And then I plug 2 in, and I'm going to get out -2. I plug 3 in, and I am back here at -1. So this is both 1 and 3. Then I plug 4 in, and I am back here at +2. And then when I plug 5 in, I am clear out here at 7. Okay, so this has some algebra stuff to it. All right, now the next thing says, okay, I kind of already told you this. This wants to know, is the object speeding up, slowing down, or having a constant speed? So what we want to do is we want to look for the sign. So this says velocity and acceleration are both positive. That means going in the same direction, so this speeds up. Now you got velocity positive, acceleration is negative, so this is slows down. And then you got velocity to the right, acceleration is 0, so this is a constant speed because it's not, the wind isn't blowing at your back or in your face, you're just doing a constant jog. Now you got velocity negative, acceleration positive, those are opposite signs, so this is slows down. Here they're both negative, so you're moving left and the wind is pushing you more left, so this one is speeds up. And then again, you're moving left, but there's no wind, so this is also constant. Then velocity is 0, that means the object is stopped, and all of these are stopped. So that has to do with what we did on the other page. Coming down here, to determine intervals where an object is slowing up or speeding down, we generate a sign chart for velocity and a sign chart for acceleration, and a third sign chart, which we will call motion, which is a product of the first two. Determine the time intervals where the particle travels on a straight line defined by each of the given points below. So what we want to do here is we want to, I thought I had, did I put that on the next page? Okay, I did not. All right, so we're supposed to have number lines on this thing, but I don't. So we're going to make our own number lines. So I'm going to take this and I'm going to get velocity. So V of t is going to equal 2t minus 6. Now we want to find when the object is stopped. So what I'm going to do is I'm going to find when 2t minus 6 equals 0, that's when the velocity is 0. That is when the object is stopped. So I know this object is stopped at 3. So I'm going to make a number line here. I'm going to start right in the middle. And I guess I should make this 0. So let's, oh man, I erased all of it. Let's put it all back. I didn't want to erase all that. I just want to erase these two things. Actually, let's get rid of that. Okay, so I'm going to make a number line and we're going to call it 0 here. So when t is 3, we want to know what's happening on, because you can't go back in time. We don't go past 0 because this is t, time. Okay, so I want to know what's happening from here and then what's happening on this side. So pick any number you want on this side. I'm going to pick the number 2 on this side. And I'm going to put it in here for this. So 2 times 2 minus 6, this is a negative here. Okay, and then I pick a 4. So I put 4 in here, and 8 minus 6, I'm just picking a number on this side. 8 minus 6 is 4. That's positive there. So what this tells me is the velocity is negative from 0 to 3, and then the velocity is positive from 3 to infinity. So that is supposed to tell me that the object is moving left. The object is moving left until time 3, and then the object moves right. Okay, now I'm also going to do acceleration. So I want to get acceleration, which I'm supposed to tell you that v prime of t is acceleration. I should have put up here that s prime of t is equal to velocity, and I probably ought to go ahead and tell them I know it's a second derivative. And so when I do the acceleration of 2t, I get 2. And so that means for the entire time, this is velocity and this one is acceleration, this object is positive the whole time. Okay? And I'm going to do this one and then call it a day. So v of t is going to be 3t squared minus 6t. So I set that equal to 0. I'm going to go ahead and factor my 3t out. So this object stops twice. It stops at 0 and it stops at 2. So at time 0, the object is not moving. So 0, it's not moving. Now if I plug 0 in there, it says 0, 0. If I plug 1 in there and so forth, I get other values, but I'm worried about, I want to know when this thing's moving, what direction. So I'm going to pick, and 2's where it stopped here and here. So I want to find out what's happening. I'm going to stick 1 in up here. So that's a positive times a negative, because that's positive 3, negative 1. Positive times a negative is a negative here. Then I pick a number over here, which is 3. That's 9 times, that's a positive times a positive, means on this side it's positive. So this object is moving left from t equals 0 to 2, and then right the rest of the time. Now I do acceleration on this one. When I do acceleration on this one, I do the second derivative of this thing, which I'm not writing the other stuff down because I'm running out of time. The bell rings and I got another class coming in. I get 6t minus 6. So I know the acceleration stops when that thing equals 0 or when t equals 1. So I'm going to come here at 1. And now I want to find out where this object is accelerating right or left. So I'm going to plug a half in here. So half of 6 is 3 minus that makes this negative. And I plug a 2 in here and that makes this side positive. So now what I'm supposed to do is tell what this object is doing by the signs if these are the same or different. So this, if I put the 3 here, this is positive forever. So over here, I know from I guess we're not really supposed to go back in time. I would probably say from 0 to 3, the object is slowing down because the signs are different. I'm going to tell why. I'm going to say because v of t is less than 0 because it's negative here, and down here a of t is greater than 0. And then from 3 to infinity, the object is speeding up. Should put down speeding up because you look up here to the right of 3, v of t is greater than 0 and a of t is greater than 0. And I should have put over here on the interval 0 to 3 up here because that's what I'm talking about. And if you probably put negative infinity to 3, it'd probably be okay. And then down here we'd say on the interval from 3 to infinity. And last but not least, we're doing the same here. So if you look, 0 to 1 is negative and this is negative to 2. So since these are both the same sign, we would say from 0 to 1, the object is speeding up because a of t is less than 0 and v of t is less than 0 on the interval 0 to 1. And then if you look here, once you get here, it's negative up to 2, but 1 to 2, 2's over here. It's still positive on this side. So that means from 1 to 2, the object is slowing down. I'm just going to put slowing because v of t, that's the top one, is less than 0, and a of t is greater than 0 on that interval from 1 to 2. And then last but not least, if you look up here, 2 is positive, and up above on the right of 2 is positive. So then we would say from 2 to infinity, the object is speeding up. And that is because v of t is greater than 0, and A of t is greater than 0. On the interval 2 to infinity. Okay, I will finish these notes at another day and put them on the Canvas page as well. See you later.